Hello everyone, welcome back. So in the last video we talked about some more challenging trigonometric substitution examples, but I hope that you've probably gotten the gist of it now. You look for patterns in the square roots and you determine how you can use a triangle to solve that. And you can also do that with completing the square, which is something we haven't talked about, but that is something that will probably come if you're in maybe a more advanced Calc 2 class. We're not going to be covering that here, but it's just something to be aware of. But you guys are probably all superstars at completing the square by now. So I would like to finish trigonometric substitution with a word problem. This is going to be from kind of an E&M electromagnetism perspective. So we'll be doing one of those problems, and I think that's going to be pretty nice. So let's have a look at it. So for this example, let's consider a rod of length L produces an electric field at the point A and B. So an E field, we usually put a vector on that E, but since we're not in vector calc yet, we're not going to be covering that. Maybe in a future course. But yeah, you could consider that as being a vector. So that is denoted by this expression. So the integral of, or the electric field at a point is denoted by the integral of negative a to L minus a of lambda b over 4 pi epsilon naught times x squared plus b squared to the 3/2 power dx. Okay, now this is a gnarly expression. Now 4 pi, we know what 4 is, we know what pi is. Epsilon naught is another one of those constants that comes up in E&M, which we'd cover later if we were in an E&M course. But let's draw this out. So in this case, the way we can picture this is we've got the y-axis here, we've got the x-axis there, and we've got a rod between 0 and L. And we've got a point somewhere out here. Let's call this P. So this is point A comma B. And we consider some of our constants that we haven't covered yet. Let's talk about those. So lambda is the charge density per unit length, and epsilon naught is the free space permittivity constant. We use that integral. So we use this integral to determine the electric field. Now, our job today is to give somebody else who might not know calculus an expression to evaluate the E field. So what we need to do is we need to evaluate this integral. And now as you see, all of this is pretty universal stuff. Like we've got constants, we don't have particular numbers, so we can generalize this a lot. So we're going to need to do a trigonometric substitution, and you're going to see right away that all of this nonsense is going to go away pretty quickly. So you've got an x squared plus b squared term. So that should be ringing tangent substitution in your head. So we're going to make the substitution x equals b tangent theta, and dx by our differentiation laws is going to be b secant squared of theta d theta. Now we're still going to be left with a definite integral when we're done, but we're going to hold off on that until we do the reverse substitution. So it's indefinite for now. So we get the integral of lambda b over 4 pi epsilon naught b squared tangent squared theta plus b squared all to the 3/2 power times b secant squared theta d theta. Now we're going to do a lot of simplification here. So we get the integral of lambda b squared secant squared theta over 4 pi epsilon naught b cubed secant cubed theta d theta. And now we can do a lot of simplification. So all of this is a constant. That has no relevance to x. So what we can do, or to x or to theta, we have no theta or x dependent. So what we can do is we can simplify this, and we're going to throw all of this outside of the integrand. So we get lambda over 4 pi epsilon naught b times the integral of 1 over secant theta d theta. Oh, well, we can do that integral because that's just the integral of cosine. So that means that we're getting lambda over 4 pi epsilon naught b times the sine of theta. Now we need to do our cool triangle thing where we determine what our values actually are, but in terms of x. So if x is equal to b tangent theta, then that means that we have this here is equal to the square root of x squared plus b squared. Now tangent is opposite over adjacent, so we have theta equals tangent inverse of x over b, so x is over b, and that's all with respect to theta there. Now sine of theta is opposite over hypotenuse, so we get x over x squared plus b squared square root. So this is going to leave us with lambda over 4 pi epsilon naught b x over square root of x squared plus b squared, and we're evaluating between negative a and a. So what we're going to do is we're only going to evaluate the fundamental theorem of calculus for this term here,